With seasonal data, like this data here, we can see regular cycles. So this one's actually a weekly cycle, which sometimes you just refer to as cyclic. But for the purpose of this lesson, we'll treat them as seasons. So what we can see is at regular intervals, there are peaks, and at regular intervals, there are troughs. And this implies that if we were to keep recording the data for multiple weeks, we'd see the same pattern. Now, in this context here, we're looking at Joe's fast food burgers, right? So Joe would expect to sell more on a Saturday, obviously, than a Tuesday. So if Joe was assessing how well his week had gone, it's important that Joe knows what his good days are and how good they should be, and vice versa, how which day he expects to be quiet, and therefore how quiet he should be. And if he knows a quantifiable number for how good or how bad those days are, he can much more accurately predict, much more accurately tell how well he's done. So to do this, you have to develop what they call a seasonal index, which is calculated as the seasonal average, which you gain from looking at multiple Saturdays in a row, okay, for a long period of time, and working out the average for that season, and divide that by the overall average. So that means the average for all of the data points for a long period of time. Okay, so the longer you can get these averages for, the better, so long as the seasonal pattern remains the same. So we're going to use these 3 weeks worth of data here to work out the seasonal index. So if we go down here, I've actually done some of that work for us. So I've worked out that the average sales per day is 42.38. So that's what we call the overall average. And that was calculated using every single data point on the graph. So all the data points we had available, and dividing by the number of data points. Okay, and that was how we got that 42.38 number. Okay, once we've got that number, I then worked out the average for each day. So I've numbered the days along the bottom here. So we've got Monday, Tuesday, Wednesday, Thursday, Friday, etc. as numbers. And I've worked out the daily average, okay, which in the formula above says seasonal average. Okay, but for this context, we're talking about daily, because the seasons are daily for this. And you can see that the averages changed. So the worst day is Tuesdays, and the best day is day 6, which is Saturdays. And the way you work out the index is as a ratio of the two. So for the index for Monday, we're going to get 25.3, and we're going to divide it by 42.3a, and you can see roughly that will come to about a half, or about 60%. So I'm just going to do that now quickly, 25.3. So I'm just going to insert a new problem here. Okay, 25.3 divided by 42.38. Okay, we get 0.597. Now let's just talk about what that means for a second. So this means that it is the equivalent of, we expect a Monday to be 59.7% of, compared to the average, compared to the overall average. Okay, or another way of looking at it is that it is 40.3% lower than average. Okay, so it's like minus 40.3%. Either way, it's a different way of looking at it, but it shows you roughly how good a Monday is. So we're going to go and work out the averages for the seasonal index for each day now. So if you pause the video, have a go at working them out and see how you go. Okay, so now we've got all the indices, we can see roughly how good each day is expected to be on average, and we'll be able to use this now to find out which the best day was for any of the weeks. So if we look at Saturday, we can see that Saturday is actually 221%, 222% of the average. Okay, or another way of looking at it is it's 122% above the average, which is fairly substantial increase. Okay, similarly, this one is 15.6% above. This one here is 15.7% below the average if we deduct that from 100. So a whole number 1 would be exactly on average.